I do for the team, and I think Sean does a bit for his team, is read through the rules and bring some of them to the team's attention at the beginning of the season. We've gone through the rules pretty quickly here, and there are a handful that have changed since last year. Now, we have 2 rookie teams, 3 rookie teams here. 2. So this will help you. These are important things we're highlighting, but you really need to read through the rules a couple of times. But for the experienced teams, the big keys are no intentional grounding to floor. So that doesn't mean you can't ground within your robot. You can't try to dissipate it to the field. Last year they said, well, you can't dissipate it this way, you can't dissipate it that way. Later on, you can't dissipate it some other way. Instead of talking about methods, they just said, don't do this. Much simpler. No EV3, kind of obvious. It wasn't an option in the past. It's now an option. They're not ready to go there. No Lego pneumatics. You used to use them, but you weren't allowed to exceed Lego pneumatic limits and use non-Lego parts in your pneumatics. They just, quite frankly, they weren't all that valuable if you stayed within those rules. They just said no pneumatics. Tetrix Prime Gripper, there's a handful of new Tetrix parts. The gripper was a pincher set that's in the new Tetrix Prime set. It's got the gears built into the gripper, so one motor can activate 2 grippers. Not a big deal. If you go to Rule 02L, it will list the complete set of stuff that are Tetrix parts that you can't use. In general, you can always use any Tetrix, any Lego. Biggies. All raw materials are allowed this year. So if it's something you can commonly buy, you're free to use it. All post-processed materials are allowed. It used to be you could have bought a piece of square channel or angle iron, but if you'd gone to that store to get the angle iron and it had holes already drilled in it, couldn't use it. This year they've just said, no harm there. Walk into Lowe's, Home Depot, Andy Mark, Servo City, any of those places, any extrusion or part they make is pretty much going to be legal.
The only limitation is that it needs to be readily accessible. Pretty much anywhere, if you can get it online, that's considered readily accessible.
And they quoted Andy Mark, I believe, and McMaster and Granger as sources. So if you can't find it in one of those 3 places, it probably doesn't exist.
Does that include grenade gears?
Yes. So that brings us to the last one of these 3, all 1 degree of freedom cots. Well, actually, a gear is a post-processed material. And then all 1 degree of freedom cots are allowed. Rule 04C. Even better. You can not only buy a gear, you can buy a gear train, a gearbox, an assembly that has a worm gear in it.
You can buy a hinge, you can buy springs,
Fully slides, don't have to.
The hinges were a weird one that used to be outlawed. You can make your own hinges. So, bottom line, 1 degree of, so readily available cots, and then 1 degree of freedom. A spring moves this way, a hinge does this way. They'd probably allow a ball joint. It's a universal joint at a single location. On the other hand, one of our alumni was involved with the gearbox stuff and first looked at that and said that no, that's 2 degrees of freedom. You have a gearbox spinning this way, but you have a shifter that switches the gearing in it. That made it 2 degrees of freedom against the rules. What would be another 2 degree of freedom? What?
I said against the rules to buy. You could still make it.
Absolutely. These are what you can buy pre-made. You can make anything. Okay? I mean, this gearbox is legal because they made it. And you could buy the gears, you could buy the shafts, you could make your own gearbox. You just can't buy a gearbox. an example of a multi-degree of freedom thing. This arm, this has about 5 degrees of freedom. It slides, it hinges, it closes, it hinges, and it spins. You can't buy this. If this is pre-made somewhere, it's against the rules to buy it. But buying all the parts to build it is just fine. And buying any one joint, any one hinge, any one pivot is fine. Combine them in your own design. Anything else on this page?
Well, the high traction wheel, I think, is another big change.
Oh, yeah.
Because I know supposable thumbs have used this wheel in the past. Now,
Sean, there's one right here.
oh,
Can you hold up? Yeah.
yeah. So apparently, so they're saying, and I'm guessing it's because of field damage is the
Yep.
reason for the rule. So a high traction wheel is not, I mean, and this one specifically is excluded, but
So they specifically excluded this wheel. They said high traction wheels that are likely to damage the field. Ferrite chokes. Anybody not know what a ferrite choke is? Okay, ferrite choke. It's a small magnetic bead that snaps around the cable or is built into some cables. Up here's the ferrite chokes. These have an electrical property of reducing high frequency electromagnetic interference on cables. So they'll help you keep your cables from acting as antennas and reduce the chance that you'll get certain kinds of electrical failures. Andy Mark never rest motors. This is one of the very biggest things. We were hoping to have a sample here today. We couldn't get it from Andy Mark. I've seen them at Indiana Robotics Invitational. It's a motor that's similar in specs to this. It's got same torque, same RPM. It's got an integrated encoder. So a $25 motor with a built-in encoder instead of an $18 motor with an $80 encoder. And it's about 1.5 inches longer, so you have to make more room for it in your robot, but you saved about 3/4 of an inch with the encoder being already built in. And finally, one of the most critical improvements they've made with this motor, they did extensive testing on stall time. So in their tests, and they don't have many working motors left because they tested it a bunch, but it takes about 2 minutes and 40 seconds at full stall before the motor is toasted. They were running that again. Now, mind you, they did test the competition also. Anybody want to tell me what it is on a Tetrix DC motor? It was 7.
7 seconds.
In Andy Mark's testing, and they burned up a bunch of Tetrix motors too, they were 7 seconds and your Tetrix motor was dead. So think about an autonomous where your robot breaks down halfway through and is sitting there stuck till the end of the period. Or in Teleop, how long it takes you to recognize it's running wild, get a referee's attention, have him find the power switch and shut your robot off. We've had, how many of you guys have had dead robots because of that? Right. If you had 2 minutes to do the same activity, how powerful would that be? I mean, I think these are going to be huge for reliability. Any quarter scale or smaller servo. So basically they've said the world's wide open on servos. This can be a significant new source of horsepower. And the hard part is 5 amps of stall current per servo control. So as you're buying servos, you have to make sure that you can find a spec for the stall current.
maybe for some perspective.
So
On the standard servo.
the standard servos are actually, so what's the standard servo? Something 85? 485. The standard high-tech 485 servo has about 80 ounce-inches of torque, and they recognize it as having 800 milliamps of stall current. So 6, the number of servos that will go into a controller, times 0.8 ends up at 4.8 amps. It actually stalls at a little more than that, closer to 1,000, but it's kind of grandfathered in. We looked at a servo that was physically the same size and had 180 ounce-inches of torque, so 2.5 times the power. However, its stall current was 3 amps. You'd be allowed to put it and 2 of the regular servos on a controller, and then you'd have to add another controller. But it might be handy to have a servo that's twice as powerful. One that I think would be big for us, motor shafts can now be modified. You're allowed to drill holes in them, put keyways in them, cut them shorter. We've had problems with set screws coming loose on motors over the years. We look at this as being the solution for that. And yes, sir.
So on the servos, is the number of servos of any type, is that the limit?
12 servos of any kind, quarter, scale, or smaller. So you could theoretically, if you wanted to run your 4 motor controllers all off of 1 port, that leaves you, 3 more ports that could each hold 4 servo controllers. 3 times 4 would be 12, and you could put 1 5-amp servo on every controller and have 12 pretty decent power sources. However, you would have 16 controllers on your robot. But yeah, that's the logical limit of this rule. Any of you guys have used the prototype board in the past? Okay. They opened up a biggie there. You're now allowed to connect an external 9-volt power supply to the prototype board, so you can now get past the very small amperage additional devices you were limited to in the past.